Okay guys, so welcome to the Naresh Technology, and today we are going to discuss one of the question which is based on the stack data structures. Those of guys who don't know what exactly the stack, so guys stack is nothing but the data structure, and as we know that data structures we are using for organizing a data in a optimal way, right? Now what is the meaning of optimal way? Optimal way means, guys, whenever you are storing a data, it will take less time, it will take less time when you are storing a data, right? When you are storing a data, it will take less time means what, guys? Whenever you are storing a data by using any kind of data structure, we'll try to retrieve that data from the data structure, it will take a less time. That is the one case. And if you are storing a data in one of the data structure, it will consume the less space. That is the meaning of optimal way of organizing a data, right? So optimal means always two things, guys. We have to optimize the time as well as we need to optimize the space, correct? Now what exactly the stack and data structure means? Generally, guys, way of organizing the data. So generally any problem that has to be solved by the computer system involves the data, and we need to organize the data in such a way that the data will get structured. Once the data will get structured, it will become a meaningful, and this meaningful data generally we call it as information. So we have to give the proper structure to the data so that it will become meaningful and become the information. Now the question is how to give proper structure to that data. For that you have to use the data structures, right? Fine. And stack is one of the data structure. Generally we call it as linear data structure, right? We generally call it as linear data structure. Linear data structure means we are storing a data inside this stack in a linear fashion. Linear fashion means one after the other. Linear fashion means one after the other, right? Now the question is, guys, what exactly stack will do, right? So stack will follow one principle, which is last in first out, or we can say that first in last out. This is the principle generally stack will follow. Means the element whichever is coming last, it will get deleted first, right? Or the element which is come first, it is getting deleted at last, right? This is the principle stack generally follow. And we have a stack has some standard routines, right? One is push, and another one is pop. Push means you are inserting the data onto the stack, and pop means you are deleting the element from the stack. As we know about the stack, guys, that stack means one end open, and one end close. So as we know that one end is open and one end is closed means we can insert and delete the element from the stack at only one end, right? So we can insert and delete the element of a stack from only one end, because we have only one side open, correct? Fine, only one end. Okay. Now guys, what we have to do, our problem statement is based on this stack, right? The problem statement is what? We have to get the minimum element of a stack. For example, guys, let me create, suppose I have a stack like this, right? And I'm pushing 10 element, right? Now I'm telling that give me the minimum element of this stack, current minimum element. So if I write here get minimum function, it will give me the current element, only one element is present inside this stack, it will return me 10, correct? Now what will happen, again I will push one more element, suppose I enter 10, 4. Now if I call the function which is a get minimum, now it will give me the current minimum element present inside this stack, which is 4, correct? Now if I perform the pop operation here, pop operation means the top of the stack, see the element whichever is at the end, it is getting deleted. Generally we call it a top of the stack. So once I do the pop operation, 4 is getting deleted. So what is the status of my stack? So my stack status is 10, right? Now if I am telling that what is the get minimum, if I call this function again, I will get the element 10, right? So the main intention of this question is that whenever I call this get minimum function, it will give me the current minimum element present inside the stack, right? So what's the approach I am following, guys? Okay, this is the simplest approach I am following, that I am taking the help of any extra stack, right? So what I am trying to say here, suppose I assume that I have elements like this, right? Consume that 10, -4, 5, 6, 12 and 7. This kind of element I have, correct? Now what we'll do, initially I have one stack because this is the stack question and we have to find out the minimum element in this stack. So I have to create a stack. So let me take one stack here, and to solve this question I will take one more stack, which is a supporting stack here, right? So what I will do, initially my original stack and the supporting stack both are empty, right? So what I will do, I will push the first element onto the stack, right? So the reason why I have taken this supporting stack, guys, I will try to store all the minimum element in this supporting stack in the current scenario, right? Now what I will do, initially my element is 10. So I will push the 10 onto the stack, right? After that, if you see here, supporting stack is empty. Now in this case, suppose anybody asks me what is the minimum element of this stack, I have to return the first element, which is a 10. So guys, what I am trying to say, all the minimum element I am trying to keep in the supporting stack, right? So I will keep here first element 10 also, correct? Now the next element came, which is a -4. Again I will push. See, you have to push all the element inside this stack. In the supporting stack, when you will push, when the element is lesser, right? So here is -4. Now what you will do, guys, you will compare this value with this value, right? If this stack, top of this stack is lesser than this one, then you have to push same value here, -4. Now if somebody asks me what is the value of, what is the minimum value of this stack, I can directly say top of the supporting stack, which is a -4, right? Now suppose I have insert the element 5 here, right? Again push, right? See guys, we are not pushing every element inside the supporting stack. We are only pushing the minimum element inside the stack, right? Now what will happen? I push the 5 here. Now I will compare this top of the stack element with this supporting stack element, correct? Now we got to know that this is already smaller, so you don't need to add this 5 inside this one, because we are keeping all the smallest element in the supporting stack, correct? Now next element is 6. Again I don't have to push this 6 element in the supporting stack because already I have a -4, right? If I call the get minimum function at this scene also, it will return -4 to me, right? I hope guys you are clear with the problem statement, right? So if I try to write out the get minimum function, it will be quite simple, guys. So if I am writing def get minimum, it's a very simple, guys. If the stack is empty, because we are giving the get minimum based on the supporting stack. If I am telling that if len of supporting stack equals to 0, then there is no element present in the supporting stack. In this case, you will return -1, right? That's it. Now, if the element is present, guys, so always top of the element of the supporting stack will be the current minimum element of the stack, right? So I will return here, I will return supporting stack of -1, which is the last element of the supporting stack. If you see here, guys, this is my get minimum function, correct? Now the question is how to push, because get minimum function is quite simple, guys. If there is no element present in the supporting stack, you have to return -1. If the element present in the stack, you have to return the top of the supporting stack element, right? Now what is the function for pushing, right? So see here, guys, now what is the scenario, right? So let me take the same example here, right? Let me take the same example here. What I will do, same. Now initially assume that both stacks are empty, correct? Both stacks are empty, yes. So what I will do, I will write a function here, def push. I will pass the element ELE, right? Now guys, what happened? Whatever the element is coming, anyway I have to push that element inside the stack. So I will write here stack dot append. I will write here element, right? It has to push. Now if I push the element inside this stack, guys, if it is a first element, and if I call the get minimum function here, definitely this 10 will be the current minimum element, guys. So if it is a first element, how I will get the insurity that it is a first element, guys? You have to check that supporting stack is empty, right? Supporting stack is empty means there is no element present in the stack and you have only inserted the first element onto the stack. So this will be the minimum element in current scenario. So what I will do, I will write a simple condition here. I will write if len of supporting stack equals to 0. If this is the scenario, what I will do, I will push that 10 onto the stack. This is the one condition. Now the next element is, see, if I call get minimum function now, it will directly give me the 10 because the current minimum element in the stack is 10. Now what is the next? Suppose I insert -4 here, guys, right? Now what I have to do? Now the supporting stack length is not 0, right? Now when should I push this element onto the supporting stack? When this top of the stack element is lesser than the supporting stack element. So I can simply say that if this is the scenario, or supporting stack of -1 is greater than or equals to stack of -1. Stack of -1. If this is the scenario, then what I will do? I will push the element onto this supporting stack. So I will write ss.append of, I can directly write the element, or you can write the stack of -1. That is also good. This is the one, right? Otherwise, then finally, after doing this, it will return. It is not returning anything. I am simply writing the return statement, right? Now, what about pop? What about pop, guys? Because see, we already defined get minimum function is quite simple, right? Nothing will be there. Push, you have to push the element carefully, right? Now, what about the pop, guys? Now listen, right? So what I will do, guys, suppose I am telling, guys, I am popping any element, I am popping 7, right? So what if, guys, if this element is available in the supporting stack also? If it is available in the supporting stack, then that element also I have to delete, right? So what is the first condition? First of all, I will write the here step pop. You don't need to pass anything. First of all, I will check if len of, this is the base case, guys. It's a kind of base case. If len of a stack equals to 0, there is nothing present in the stack, I will simply return -1, correct? Not at all issue, right? Now the question is, now suppose I have to pop. Pop means always the top of the stack element is getting deleted, right? Because it's a principle of stack, the last element is getting out first, right? So what I will do, I will first, because we don't have to lose that element. The reason is what, guys? If same element is passing here, with whom you will compare them? So what I will write here, simple scenario, I will take one variable called result, right? I will assign this stack of -1 to this one, right? Now after this, I will do one thing, guys, stack dot pop of -1, right? I will directly pop, because 7 is not present in this one, no issue, you can directly pop the element from this stack. Now what if, guys, suppose you pop all this element, right? Suppose you pop all this element. Now if you wanted to pop -4, now you have to pop this -4 from this supporting stack also, right? If you have a -4 here in this stack, and you have a -4 also present in the supporting stack. So if you are deleting from here, then you have to delete from here also. So what I will do, because I already popped this one, and I stored this -4 value in one of the variable. Now I will check, guys, simple. Now what I will check, if result equals to supporting stack of -1, if this is the scenario, then what I will do, guys, I will write supporting stack dot pop of -1. That's it. If I return this, it is not returning anything, I am simply writing return, right? This is the code. Very simple approach, guys. Okay, if you wanted to calculate the time, because we know that it is taking very less time, guys, okay, because we don't require much comparisons here, right? How many elements for pushing the element onto the stack and popping the element from the stack, it will take order of 1 time, right? But only one thing is required, guys, here, only one thing is required. We require an extra supporting stack, which will take the extra space. That's why the space complexity will become order of n, which is the size of the stack I am considering as the n, right? So this is a very simplest approach, guys, to do this thing, right? I already written the code here, okay? In the next session, we'll exactly see, we'll code this question also, and we'll also see how I will solve this question in order of 1 space, because, guys, it's not a good approach, although it's a simple approach, but I wanted to solve this question in order of 1 space. That will be the better approach in this case, without using any extra supporting stack. I hope, guys, this is a quite simple question. So we'll see more question. We'll code this question in the next session, as well as we'll see the optimized version of this question. Thank you so much.